Welcome to lesson 2. Let's look at this. The exact value of a function at a particular x is not relevant to deciding whether a limit exists. What does that mean in practice? We're going to make up a function. So I'm going to write f of x. Remember this following. F is the name of the function, x is the input, and then f of x is the output. F of x doesn't have any other meaning than that. It just represents the output for a particular x that goes into f. And then here I'm going to do the following. I'm going to define a function in two pieces. So the first piece could be, say, negative 3x say plus 2. And that will be used when x does not have the value 1. And then after that, what I can do is, I can, for example, have 4 as the output when x does have the value 1. This is a piecewise defined function. Let's make a graph of it because graphs here really help. Alright, so I'm going to graph the following. I'm going to graph negative 3x plus 2. And you see, this is also pointing out an important issue with a lot of graphing software still, which is that this will just, at positive 1, show you that the value of the function is negative 1, which is not correct according to our definition. So what I'm going to do is the following. First of all, I'm going to pull this down a little bit. Where normally you would have a point, you don't have a point because I defined the value of the function to be 4 at x equals positive 1. So at positive 1, there should really be a hole. That means that the value of the function should be marked in the graph using a dot. And when x has the value 1, you should be at 4 right there, you see? Now we have to study what happens when we take a limit around x equals positive 1. In other words, here's a question. What is the limit of f of x as x approaches 1? We want to answer this question somehow. So I'm going to type the following. F, and I'm going to grab a value of the function to the left of 1, but close to it. That's important to understand. You don't want to grab a value that's very far away from 1. Because then that's not useful. You want to see what happens around x equals positive 1. So I'm going to grab a value like 0.999. That's very close to 1, but to the left of it still. And then you plug it in. So it's going to be negative 3 times 0.999 plus 2. You punch this into a calculator and you find that the value is about negative 0.997. Grab a value to the left of 1, but closer still. Like for example, f of 0.9999, and then see what happens to the output. So it's going to be negative 3 of 0.9999 plus 2. You punch this in and you find that it's equal to negative 0.9997 this way. You can see that that seems to be approaching negative 1. And it's confirmed in the graph. If you look very carefully on the left side, you see the values as x approaches 1. From the left side, the values of the function are moving towards negative 1 from above negative 1, you see? Now let's study to see what happens when we approach 1 from the right side. So you're going to do f of the following, 1.001. I'm plugging in a value of x, 1.001, very close to 1, but to the right of it. And I'm going to do the following, negative 3 times 1.001 plus 2. You punch this in and you find that this value is negative 1.003. Do f of 1.0001. That's really close to 1, but still to the right of it. It's going to be negative 3, 1.0001 plus 2. Punch this into your calculator and you find that it's equal to negative 1.0003 with 3 zeros there. You can visualize that aspect of the process by doing the following. When x is approaching, look carefully, 1 from the right side, you see the values that are output are sliding towards negative 1, but they're doing it from below, this way, right there, you see? What is this suggesting to us? It's telling us the following, if you look carefully. This is approaching negative 1. These calculations are approaching negative 1. Therefore, the overall conclusion is the following, that the limit, as x approaches 1, of f of x is negative 1. The value of the function itself, remember, at 1, f of 1 that is, the way we defined it is that it's equal to 4. We can also say the following then. The limit, as x approaches 1 of f of x, is not equal to the value of the function at 1. It doesn't matter. It doesn't have to be that way. The limit still exists. In other words, the essential idea for you to take away from this lesson is the limit describes what happens to the outputs. As x, for example, gets approached from the left and right, what happens to the y coordinates? What are they approaching? In other words, you see, this is kind of emphasized in these calculations, right? These here are approaching negative 1. These here approaching negative 1. All right, and this is a wrap up then on lesson number 2. Thank you, friends. I'll see you in the next lesson.